Okay, you can start it now.
Okay, so hello everyone. Today we're going to go over LeetCode number 304. This is a medium question. It's a non-premium question, and it really tests your understanding of prefix sums because, it requires you to optimize. So this one's called range sum query 2D immutable, and the idea here is pretty simple. So you're given a grid, a 2D list of integers, so a list of integers, and you want to find the sum of a particular rectangle or square in the grid, and you want to do it efficiently. So yeah, pretty simple. So the easiest way to do this obviously is just from the boundary. So row 1 and column 1 is going to be the top left corner. So this, and then row 2, column 2 is going to be the bottom right corner, right? So this bottom right, and then, right? So define an integer because we're expecting a return type of an integer, and then just iterate from row to row, from left to right, and then from top to bottom. So row 1 to row 2 plus 1, because Python goes up to not including this part. And then for J and range, column 1, column 2 plus 1, same thing. Because if you do column 2, this is up to not including, so we plus 1 to offset that. And then we add this is a particular index, the row and the column inside of the input list of lists that they gave us, and you can return result, right? This is fine, but it's going to time out because this is O of n squared. As you will see.
It's still loading, right?
So 15 out of 22, I mean, technically works, but the big inputs like this, it's not going to do it. So if you make some observations, let's play with some test cases and see what we can do right here. Let's take this row, for example. If you notice something, instead of iterating through the whole row, let's try to apply prefix sums. So what is the sum up to this point? It's 3. What is the sum up to this point? It's still 3 because 0 plus 3 is 3. What is the sum up to this point? It's 4. The sum up to this point is 8 and 10. So this is just accumulated. Now, if you want to get a sum of a particular region of the array, observe that it's the current accumulate minus 1 of the previous accumulate. So this region is 8 minus 3. This region is just 4, while this region is 4 minus 3, which is 1. And if there's no left region, if we're here, then just the whole thing up to whatever point, right? So if you know this, you can turn this from an O of n squared into an O of 1 solution, or O of n solution. So let's create a prefix array and iterate over, or A in matrix. So getting each row of the matrix, right? Because our matrix is, for example, is this. So going row by row, and then Python has a nice iter_tools.accumulate that basically does this for you. Accumulate A, so the row, and if you print the prefix, you will see. So right now, let's just use a dummy value, return 0. I just want to show you. So this needs to be a list, not just accumulate. So now you can see 3, 3, 4, 8, 10, right? That's going to accumulate everything. And now let's apply what we know about the prefix sums. So instead of O of n squared, let's just iterate over row 1 to row 2 plus 1. And now, the column 1 is the left boundary, right? So we have a right and a left boundary. So if we want the sum of this, then the left boundary is this for this current row. So we still have to iterate over every row. But now if the column 1 is less than or equal to 0, then everything up to that point counts. So then we can just add to result self.prefix the current row and then column 2, because column 2, for example, would be here if you want to get everything up to this point. And then otherwise, if it's bigger than 0, then we can apply exactly what I told you, which is to get this minus this for this. So self.prefix of I column 2 minus self.prefix of I column 1 minus 1. the -1 is super important because everything up to that point is the accumulated up to this point, and then we have to subtract the accumulated of the current point minus whatever was before our current window that we want to get the sum of the subarray of, right? And then at the end, then we can just return the result. And that works, that passes the test cases, and it is a better approach. So that's my way of doing it. I hope you found this helpful.
I think it's very helpful, but I think you also need to looking for more optimal solution, right? Because you see, not just achieve 12%. Okay.
Okay.
Maybe you can run one more time. Maybe you're getting better time
Well, I
capacity.
mean, it's optimal, but this is my way of doing it. I came up with this by myself. That's the point.
Okay, yeah, it's good. Yeah. Okay, I will